Hello, I'm William Calvin, a professor at the University of Washington in Seattle. This is the first in a series of talks on human evolution. To appreciate how much evolution accomplished in the last 6 million years, one must appreciate what was present when the pre-human branch split off from the great ape tree. And so this lecture, Great Apes, the baseline for human evolution. I won't go all the way back to the Big Bang in my little history, but if you want to understand where the primates come from, one has to start at the Cretaceous extinction, 66 million years ago. All of the large body species went extinct, including the big dinosaurs. The small dinosaurs, which we tend to call birds, survived and went on to evolve the songbirds. Small mammals thrived afterwards as well, and went on to spin off the primates. Then the primates evolved about perhaps 60 billion years ago. They were tropical tree dwellers, and the best stand-in for them is probably the ring-tailed lemurs, which you see here. They're about the size of cats. But the ancestors were probably a bit smaller than that. Those nocturnal little guys with the big eyes are the other prosimians that are common. From such ancestors, the monkeys evolved. Monkeys kept the tail and used it to help balance themselves as they walked along the top side of branches in search of fruit. From prosimians to monkeys at 34 has a parallel development that's dated back to at least 32 million years ago. The ape lineage starts up really at about the same time as the monkey lineage does. They're parallel developments, not so much as one coming out of the culmination of the other. The earliest apes are found in Africa. Tailless, brain size bigger, ape shoulders more versatile, but the elbow joint got a socket that permits them to support their considerable weight along a straight vertical line. Monkeys can't do that. Only 6 apes survive. The 2 small apes are the gibbons and the siamangs. Now let's move on to the great apes with their larger body size and more recent evolutionary history. The ancestral great ape probably attained its large body size in Europe about 14 million years ago, where Hungary is today, or where the fossils are. A long lifespan tends to go with large body size, and that long lifespan is crucial to maintaining culture through learning. If you don't have a good way of copying what someone else did, inventions tend to die with the inventor. The great ape represents the major step up in intellectual abilities before the second big step up to humans. After the great apes developed in Europe, they spread into Asia, and the only remaining species of that lineage comes from Southeast Asia, the orangutan found on the tropical islands of Borneo and Sumatra out at the west end. Another branch of the European apes went into Africa. These African apes diversified into the gorilla, the chimpanzee, and the bonobo, and us. The oldest of the surviving great apes is the orangutan, whose ancestors likely evolved in either Europe or the Indian subcontinent about 12 to 14 million years ago. Today, it is found only in Southeast Asia. Another branch of the European great apes followed the shrinking tropical forests south into Africa. Let us begin with the oldest, the gorilla. We last shared a common ancestor with them about 7 to 8 million years ago. Gorillas are basically vegetarians. They eat big leaves and a lot of bamboo, and like other herbivores, they're not particularly smart. They have enormous digestive tracts in that big belly of theirs, and they need this to extract the barely 2% of the calories present in the leaves as they pass through the tract. And they'd be gain 1% if they had a digestive tract only half as long. Gorillas exhibit very little tool use. They usually fail the mirror self-recognition tasks we'll come to at the end. Somewhat more recently, the genus Pan split off, diversifying into the chimp, Pan troglodytes, and the bonobo, Pan peniscus, about 2 million years ago. The other branch at 6 million years were our ancestors, the hominids. While the bonobo was formerly called the pygmy chimp, that was a misnomer. Short for the chimp of the pygmies, that tribe of short stature that has adapted to the diseases of the tropical swamp. Bonobos are also called the left bank chimps, a good pseudonym for 2 reasons. One reason to call them the left bank chimps is they live only on the left bank of the Congo River as you float downstream. I'll tell you the second reason later. Chimps and gorillas live on the right bank of the river. Indeed, the chimps extend west through Nigeria and the chimps all the way over to Senegal. On the east side, the chimps extend past Lake Tanzania, where Gambia is. Gambia is where Louis Leakey encouraged Jane Goodall to go observe chimps in the wild. That was in 1960. Also the year that Louis Leakey, in passing, encouraged me to take an interest in hominids by fishing in his pocket and pulling out a fossil tooth from Olduvai Gorge and handing it to me. I was a physics major at Northwestern who had talked my way into what turned out to be a graduate anthropology seminar, a gamble well worthwhile. Over on the right, you see the Rift Valley. That's at the very top is in Ethiopia. Right on the equator there is in Kenya. And that starburst that you see is Olduvai Gorge. The other hominid fossil sites include Laetoli, where the famous footprints are at 3.3 million years, showing how much upright posture and walking they had. This is the West Turkana area. That's Lake Turkana up there on the Ethiopian border. And then further up is the Hadar region, the Middle Awash Valley, where so many fossils have been found, including Lucy. And then again, down near the equator, the Tugan Hills area has been a place where some very early hominids in the 5 to 6 million year range have been found. So this is the basic summary of the family tree I've just outlined. I'm going to use it to tell you what's coming next. We're going to discuss portraits of the apes. I use a lot of pictures to show you some of the things that we have in common with the apes, but I'm going to have to start back early because some of the things we find most engaging are in fact not unique to the more recent human ancestors. We're going to discuss the play face, And then we're going to discuss mutual grooming, which is a emotional satisfaction. It's very important in human evolution. Then I'm going to discuss expressions that are seen only in the great apes, as in monkeys don't have the muscles to make them, among other things, and they don't have the behaviors that go with them. I'm going to discuss emotional reassurance and empathy. Then we'll move to the topic of sensation seeking in bonobos. There's a big development, as important as the big brain development, and that's the evolution of sharing, cooperation, and with sharing comes the problem of dealing with the freeloaders. And we have a number of built-in instincts regarding that. Then I'm going to move to imitation and tool making, and finish up with self-recognition and walking upright. But you know this is play when you see it. But what tells you that? It operates at a very deep instinctual level, no learning required in many mammals, including us. It can be recognized cross-species quite easily. You're familiar with the play face from dogs offering to romp. The eyes are wide open, and the lips tend to be rounded inward or relaxed to partly cover the teeth, quite the opposite of an angry baring of the teeth. This opposite expression signals the playmate that this isn't really aggression, it's only pretending. You can find this even in polar bears, even cross species, this illustration shows. Here you see the play face in a juvenile bonobo, in a orangutan. So in primates, in monkeys, grooming seems to have considerable importance. I mean, monkeys love to groom and to be groomed. It's a major focus of their social life, and it's very good for calming down an upset monkey, or one who, because he's the alpha male, needs constant reassurance. Here's an example in gorillas that sort of looks like a drill sergeant is chewing out a recruit, but in fact that is grooming. The Kabara on the right is using her lips to comb the facial hair of Jomani. They also discover insects this way, which they enjoy eating. Here's Pan Venetia as an adult, but when she was only about 6 or 7 years old. She was once fascinated with my beard. She kept asking for permission to touch the visitor, and after several weeks of this, she finally got the okay and promptly climbed up into my lap, flipped on her back, and diligently inspected my beard. She was soon disappointed, climbed down, and lost all interest in me, even though I groomed her back. This might be more cautiously described as a bout of mutual grooming, not smooching. Bonobos do kiss, and perhaps it evolved out of nibbling-style grooming. Bonobos even have the reddish lips, unlike the other apes for whom kissing seems to be without sexual overtones. So now at this point, we're going to start listing uncommon features seen in the portrait, ones that make their first appearance only when we get up to the great apes. The royal wrist, that is to say, adult apes may extend the back of their hand to be kissed by an infant, which reassures it. Patting, the reassuring touch, and the arm around the shoulder, all seen in great apes. Kissing and embracing, seen particularly in bonobos. Certainly none of these are seen in the monkeys or the rest of the animal kingdom. This quote from Franz de Waal, I'll read it out loud. At emotionally meaningful moments, apes can put themselves into another's shoes. Few animals have this capacity. Monkeys fail to provide reassurance, even if their own offspring has been bitten. They do protect them when attacked, but show none of the cuddling and stroking with which an ape mother calms down an upset youngster. Here you see some facial expressions in a adolescent chimpanzee. Below, you can see her still disgruntled with whoever she was addressing at the top. And pretty soon you see the following expression, a pout. So there's a substantial part of the human range in emotional expression already seemed to have been there before the hominid evolution branch began about 6 million years ago. There's even an expression common to fathers when they're swallowing infants, as seen in bonobo. So let me now go through the differences between chimp and bonobo just to help you appreciate the visual differences. Major difference, of course, is left bank and right bank of the Congo River, but the stature of a bonobo is equally tall as the chimp. They're built a little bit more like quarterbacks rather than like football linemen, which would be about the characterization of chimpanzees. But in overall stature, they're certainly not pygmy. Easy way to identify is if you see a white beard, it's a chimpanzee. Neither gorillas nor bonobos have that short white beard. You might notice that there's reddish lips in quite a few bonobos. That's not seen in any of the other great apes. There's a center part to the hair in bonobos, very characteristic of them. Chimps have somewhat bigger ears. Chimps have somewhat smaller eyes, more close set. It's no greater than the differences between the people of North Asia and of South Asia. The bonobos have long tufts of hair that stand out to the side. In chimpanzees, the face color varies during life. What you're seeing here is an adult male on the right. But when they're younger, they have this tan face that you see on the left. That youngster is about 5 or 6 years old, I'd say. The one on the right, which only has a bit of tan around the sides, is probably 11 or 12. Here's 11-year-old Goya again with the pout. And she's 11 at the time of this picture, and you can see that there's various dark spots coming in, filling in the face. So why use great apes as the starting point for this? They're almost us when it comes to emotional expressions and postures. Oh, lots of little things that seem very familiar to us and which monkeys don't evoke. And then there are the sensation-seeking behaviors, particularly in bonobos. Here is Junior, a bonobo. I think he was about 11 years old when this was taken. And what he's doing is spinning around to become dizzy. Same way children will use a playground swing. all curled up to spin around and become dizzy. It's just sensation seeking. You can also see them tickling one another with an object. Here is that guy again. He is just pitched downhill. He was standing up on the hilltop, and he just pitches down finally when he gets dizzy enough. And you should note that dopey expression on his face. Here's another example spinning around in Macumba, a female about age 7 here. And I've seen her spin several dozen times like this. She's holding on to a branch of leaves that she'll eat later and just using it to swing around and around. So real practicing, is just not seen in the great apes. But maybe this is how it got started, sensation seeking, giving them lots of practice. Here's Macumba again, and what she's doing is leaping up at a wall of the enclosure. She's not trying to escape. The wall is at least 3 or 4 times too high for that. What she's doing is doing backflips off the wall. I mean, watching her, you would have said she was practicing, but maybe, again, she just liked the sensation and was repeating it for pleasure, the way children will spin themselves. Come to see. You can see bonobos play a version of blind man's buff. I mean, holding a hand over his eyes or draping a blanket over his head, and then showing off how well he can balance on a rope without looking where he's going. I once watched one bounce around off all 4 walls of a room doing this with a blanket over his head. The other thing that you might put under sensation seeking is frequent sexual intercourse. I mean, frequent in a way not seen in the other 3 great apes. Furthermore, there are various non-reproductive sexual behaviors like masturbation that are occasionally seen in chimpanzees, gorillas, and humans, but they're seen in almost every bonobo, though for males without ejaculation. It is said that chimpanzees resolve social conflicts with power, while bonobos resolve them with some sort of sexual activity. Here you see Bacassi at age 2 hoarding some nesting material for the night. I just wanted to mention here that great apes do not reuse the night nest they build. They build a new nest each night, usually up in the tree. But possession is the start of the discussion of sharing. Possession seems to confer ownership in some sense. At least among adult apes, it's generally respected, this possession. That's probably why you see so many zoo apes carrying branches around draped over their shoulders. Leave it somewhere and someone else will take possession and own it. Now, this kind of respect for possession is not common, really, certainly not in monkeys. The monkeys higher up in the pecking order will simply plunder the possessions of juveniles and weaker members. But in chimpanzees and bonobos, at least, you see this notion of possession, so that even a junior animal with, say, meat will not have it plundered, even though the senior animals will stand there begging for something. So here's a quote from another primatologist. Except from mother to infant, food sharing is not common among primates. We see it in a few species when males have meat and share with their consort of the day. going off in the bushes is very common chimps. Within same-sex pairs, it is found only in some highly tolerant capuchin monkeys and great apes, chimps, bonobos, and orangutans, but not gorilla. Here's about as far as you see sharing. This is what I would call tolerated scrounging. That is to say, the possessor doesn't hand it out, keeps good hold on it that will allow a companion, in this case a grandson, to nibble at some. I mean, it's a long way from going around and offering food to strangers one at a time, but tolerated scrounging is a start. On the other hand, here's Winston's 4-year-old grandson, Ajari, again, who is obviously hoping that his grandfather will share some bamboo leaves that he did not. So he stuck around, staying in plain sight, just hoping, and then finally he gives up and goes away. And here you see a gorilla out. Meat is the chimp's favorite food, yet they share it when they catch small monkeys or pigs. There's no plundering, so it does show this violation of the usual hierarchy where Junior eats last. But it is really a lot more like in-your-face aggressive panhandling, hand palm up, than it is like voluntary sharing. And what's dished out is only the barest scraps. So the evidence for great apes sharing outside the parent-offspring context is weak. But food sharing and group cooperation are one of the most important developments between great apes and humans. So I'm going to give you my candidate for the foundational events. Small game, as you see on the hair there on the left. Small game, if you can catch it, is a meal for only a couple of people. Large grazing animals are another story. Grazing animals have to visit a water hole every other day. Browsers get enough water from the leaves that they don't have to. So the development of grazing animals from the mixed feeding herbivores was an interesting development because it allows the predators of large grazing animals to just sit at the water hole and wait for dinner to come. Now, acquiring meat in large packages means that it's too much to eat yourself. And so, large grazers are a great setup for evolving more and more sharing. So apes are reluctant to share, but just to show you the big gap, sharing on the first meeting is pretty much the default these days. After that first courtesy, reciprocity often determines if human sharing continues. There's a reason that we now all have strong instincts to return an invitation, lest one be thought a freeloader. Combating freeloading is a problem at every step up into more and more sharing, and that's what happened in the 6 million years we're talking about. Humans have developed an instinct to combat freeloaders, even at a cost to oneself. For example, there are things like road rage, where someone with nothing to gain undertakes to punish a cheater at likely costs to oneself. I mean, this is a strong instinct, though culture can certainly limit it. Now let's examine another big step up between great apes and modern humans, the ability to imitate. A cognitive system for imitation arises in humans during the first year. Only orangutans among the great apes show a distinct capacity for imitation, but it has an odd setup. In orangutans, the basic family group is the only group. That is to say, orangutans live solitary lives in the wild because their food is spread out so thinly that each animal needs a big territory to gather the fruit from. And so a mother and her offspring is just about it, except for the occasional twin. And youngsters, in consequence, have no playmates for their first 8 years. Orangutan offspring, however, must learn food acquisition from their mothers over this 8 years. The youngster will patiently observe her opening prickly fruit shells and then try later. This system perhaps succeeds because there are no interruptions from playmates while trying to observe and then imitate. That's why I say this is an odd setup for more and more imitation, but orangutans are exceptionally imitative. Supina, a young adult female orangutan at a rehab center in Borneo. Rehab centers are filled with juveniles that have lost their mothers, usually because they've been shot by farmers. So the youngsters all wind up in a rehab center where they try to teach them, something about gathering their own food, but while supplementing it. So Supina turns out to have just spontaneously started hammering nails after having watched the native carpenters. She sawed wood. She would sharpen axe blades. She chopped wood. She dug with shovels, siphoned fuel for the camp stove, swept porches, painted buildings, pumped water, blew blowguns, and learned how to fix the blowgun darts when their feathers got ruffled. Supina lit cigarettes, almost lit a fire, washed dishes and laundry, bailed water from a dugout canoe by rocking it from side to side, put on boots, tried on glasses, combed her hair, wiped her face with Kleenex, carried parasols against the sun, and applied insect repellent to herself. Whatever the job involved a complex technique, like lighting the stove. Hers matched the technique that was used in camp. There's just nothing like this in the other great apes, except for us. So let's discuss tool use. That you're probably familiar with chimpanzee nut cracking in West Africa. And in East Africa, fishing for ants. It's called anting. This kind of tool use is also accompanied with some tool making. That is to say, they have to strip the branches off of that long strand of plant in order to make it useful. But this is not the kind of tool making you probably anticipated. When fruit is out of reach, some chimps and orangutans will use a long stick to hook and pull down the branch, and gorillas in zoos have learned how to do this as well. Wild chimps will use a stick to comb tangles out of their hair. Satu here, about 13-year-old orangutan. Satu is not trying to start a fire after seeing a Boy Scout using this back and forth sawing motion. What he wants to do is to abrade the inner surface of the bark strip, probably willow bark, because that would free up a nice taste. Indeed, this is where things like aspirin, come from in nature. And is really as something approaching creativity that one can see here. This quote from the primatologist Benjamin Beck, who's at the National Zoo in D.C. If you happen to forget a screwdriver in the gorilla cage, the animals the next day will hesitantly approach it, briefly sniff it, and subsequently ignore it. Leave it in a chimp cage, and it will be used in vigorous displays, thrown about and forgotten. But if you leave it in the orangutan cage, one of the animals will unobtrusively pick it up, hide it, and use it to let itself out when you've left for the day. Now I'm going to discuss groups, not so much this friendly group that's hanging out in the shade together at the San Diego Zoo, but I want to discuss some of the consequences of the kind of group. Bonobos and chimps live in multi-male, multi-female groups. When a female's an estrus, most of the group's males get a chance to mate with her. This is like a lottery. A male's chance of siring an offspring depend on how many tickets he can manage to buy. Those with a large sperm factory tend to win. In a gorilla-style harem, a small factory will suffice, because no other male is likely to mate during that cycle. Mountain gorillas used to live in this sort of harem-style group, one dominant male for a few years, with other males driven out of the group when maturing, and gorillas have small testicles. But since the 1990s, something has happened, and it's not clear why. A chimp-like multi-male group of gorillas has been seen, and still with a male dominance hierarchy. It's not a complete parallel to the chimps. And since the 1990s, such multi-male gorilla groups have been seen to attack and kill loner males trying to join the mixed group. And the groups attacking, a huge pile-on and chewing of the throat and such, will include females and juveniles attacking. This is not seen in chimpanzees. First of all, chimpanzees seek out targets on the periphery of their range, and at least you can find a genetic rationale for why that might be somewhat better, because they are getting more territory, more food, more youngsters grow up. But in this case, with the gorillas, the males that were attacked were loner males who were trying to join the group. And they would not necessarily be attacked immediately, but after trying to pal around with them, a dominant male may start an attack. And what I've just described is everyone else in the group piling on. So it's both of them are a lot like gang warfare. And these are 5-on-1 attacks. Chimps and humans exhibit both the cooperative hunting of game, full of instinctive army patrol type maneuvers, and the 5-on-1 gang warfare that often kills a lone neighbor. But Godby's 5-on-1 gang warfare involved chimps who actually knew each other. Any association with the enemy was grounds for attack. So, continues Franz de Waal, us versus them among the chimpanzees is a socially constructed distinction in which even well-known individuals can become enemies if they happen to hang out with the wrong crowd or live in the wrong area. I'd say none of this is seen in bonobos. Now, chimps, while they do engage in these gang warfare attacks, haven't extended to the kind of violence that requires a bit of planning, like middle of the night raids for plunder and rape. That's not seen. Nor have they advanced to war, which needs even more planning. You have to stockpile things, you have to train. War is seen only after agriculture develops 6,000 to 10,000 years ago. It's only seen then, and then it's only seen seasonally after the crops are in. There's a labor surplus then for several months, and as recently, 400 years ago, the 100 Years' War in Europe was fought seasonally. All right, to finish up, I want to cover the self-recognition test. Some animals recognize themselves in mirrors, but there's, in the great apes, a fair amount of variation, and there's not much of it in the other animals at all. Here's a big silverback male with a mirror that's been constructed alongside a trail. And this guy apparently thinks that that's a different male gorilla facing him. So let's look at the movie briefly. Like monkeys, nearly all gorillas fail to recognize themselves in a mirror. The other adult great apes, on the first time they are given a mirror, instantly recognize themselves. Usually, they open their mouth and move their tongue. Next, they use the mirror to examine their backsides, but not gorillas. Sometimes they go so far as to embellish themselves. Presented with a mirror, Soma, an orangutan at the Cologne Zoo, gathered salad and cabbage leaves from her cage, placed them on top of each other, and then put the whole pile on her head. Staring in the mirror, Soma carefully rearranged her vegetable hat. Let me speak briefly about language abilities in the great apes. They have, even more than monkeys, some characteristic vocalizations that you can learn the meaning of by enough observation, but they're really capable, given the right rearing environment, of doing a lot better. Kanzi, 25 in this picture, can understand a few hundred words and act accordingly if requested to do something. Not only can you get him to act on simple sentences like, give me the red ball or something like that. He's not necessarily trained with red balls, but he knows red and so on. So there's a series of tests they use of things that they haven't taught explicitly. And Kanzi can understand and to some extent produce himself 2- and 3-word sentences. But he can understand long, complex sentences. Go to the office, Find the red ball and bring it back here. Now, the office is not normally a place where there are balls of any color, but he will ask to be let out of the test room into the outdoors. He asks to be let into Sue's office, and lo and behold, it's filled with balls of all sorts of colors. He gets a red one, and he retraces his steps back into the test room and presents it. Okay, that's a level of competence that's about equal to a 2.5-year-old child. They tested the daughter of one of the psychologists working with Kanzi on the same thing. Usually the teaching was done via written symbols, but it turns out that Kanzi picked up the spoken version, which they always did in parallel, just as well, and that for many words the keyboard thing could be dispensed with. Now, we have a basis for saying what the level in the great apes was of language abilities, not necessarily used in the wild, but what they can be trained to do. Some of them have the brain that will allow them to do this, others are complete duds at it. Now I'm going to discuss bipedal woodland apes. They evolved from the branch that goes off to the chimp and bonobo at about 5 to 6 million years. The Australopithecines are the genus that you've heard about most. What happens over the course of about 3 billion years is they become fully bipedal in the sense that they have an efficient walking stride. Nothing much seems to happen to the brain, at least as far as size goes, in that 6 down to 3 million year period. Now let me discuss bipedality a bit. Monkeys walk atop tree branches in search of fruit. If they have to reach a hand out to pick the fruit, they have to counterbalance so that they don't rotate off the branch. Here you see a better way to pick a lot of fruit. Monkeys cannot do this without straining their elbows. Their elbow cannot lock in a straight line, taking the weight off the ligaments. Ape elbows lock, allowing them to hang vertically for long periods. The back of the elbow has a deeper socket in apes, allowing the forelimb to hang straight when vertical, supporting the body's weight. So bipedality, or at least upright posture, developed 30 million years ago. Now, upright posture and upright stance are another matter. That requires, if you're going to do a lot of it, some hip rearrangements and such. When we see bipedal gait, it's often a left-right weight-shifting sort of thing, essentially waddling, rotating the body atop the weight-bearing leg each time. This is tiring to do for very long. Incidentally, note that play face on the bear. Okay, here's an example of one of those moai, or a fiberglass replica of it from Easter Island. And this is a team demonstrating how they could have transported it from the quarry to the display sites along a meeting ground. People had always wondered how they transported them, and this is a simple demonstration showing how they can be walked by waddling all the way along the road. So the human style walking developed between 6 and 3.3 million years, where those Laetoli footprints are. Most bipedal animals don't walk the way we do. Humans are unusual in that rapid walking is a controlled fall forwards, catching yourself with the free leg and then repeating the opposite side. So you put a foot forward and then fall into it. And the momentum that you gain that way carries the hip forward and swings the other leg forward, and you fall into it. It's a very different kind of bipedal gait than you'll find in other cases. So we have done the bipedal part. Let's finish up with the woodland part. This is basically ecology and population ecology at that. I'm going to just give you a quick introduction to the big setup for what we're going to cover next time. The expansion out of Africa and the ramp up at brain size. The fringe of a forest tends to be woodland. There's not enough soil moisture there to support big trees, so you get small trees. In the drier areas, you get grass. That's a woodland, mixed trees and grass. Now, as the Miocene cooling progressed, it also became drier in Africa. And Africa, formerly almost entirely forested, broke up into various smaller pieces. So there's a fragmentation of forest. And that means that there's a great deal more fringe around all those separate pieces than there would be when it was large. So more and more woodland became available, and our ancestors specialized in woodland. There is where they made the transition into grass-fed meat, but still trees for refuge. Well, this is not really the most recent great ape. It's a female gorilla. But this is the most recent great ape, Homo sapiens. That's where we're going next time. Here's the family tree again. We've covered that much today. Next time we go through the ascent of the Australopithecines in their woodland, then into Homo erectus out of Africa, and then another out of Africa that takes Homo sapiens from Africa worldwide. If you need to read up on some of the things I've mentioned today, you might find the references in my book, but the best place to read up on this stuff is in any of Frans de Waal's books. There are 10 of them that you'll find, and every one of them is a jewel. I suggest you try some. Next time, the lifestyle that led to humans.